This is going to be a quick video that reviews ionic compound names and formulas. It seems like from class most people understand covalent naming and acids, but there's still some confusion with ionic names and formulas. So this video will just guide you through some of the basics again and help you refresh your mind about what to do when you're writing a name or a formula for an ionic compound. I just want to start with a quick review of ionic bonds. If you remember, ionic bonds involve the transfer of electrons. One element has an electron or electrons that it doesn't want, and these would be your metals. They want to get rid of electrons. And then you have another element which wants to take the electron or electrons, and this would be your nonmetals. They want to gain electrons in order to be happy. Remember, every element wants to have 8 outer or valence electrons to be happy, and metals will get rid of electrons in order to do this, and nonmetals will gain electrons in order to be happy. It's important to remember that ionic bonds involve a metal and a nonmetal. If you see a formula or you see a name of a compound and it has a metal in it, that is an automatic key that the compound is ionic. So don't forget, if you see a metal, that tells you the compound is ionic, and you have to write the formula or name following ionic compound rules. Let's start by naming ionic compounds. So if you were given a formula and you had to write the name of that compound, these are the steps that you'd need to do. First, you need to look at the metal in the compound. We know that these compounds have metals because they're ionic, and all ionic compounds have metals in them. And the metal is always written first. So you look at the first element and you ask yourself this question: is the metal multi-charged? Well, what do we mean by multi-charged? Well, that means it has more than one charge, and we don't know what that charge could be. So if the metal is in the middle here, in the D block, then the answer to that question is yes, it is multi-charged, and you'd have to follow the steps that I'll show you on the next slide. Also, if that metal is lead, Pb, or tin, Sn, then the answer is also yes, because these elements act like the multi-charged metals of the D block. If the metal is zinc or silver, zinc here or silver, both of those are in the D block, but they do not act like multi-charged metals. Zinc always has a 2+ charge, and silver always has a 1+ charge. So if the metal was zinc or silver, the answer to the question is no, and you'd have to follow a different set of steps. So you look at the metal and ask yourself, is that metal multi-charged? If it's in the D block, the answer is yes, except if it's zinc or silver. If it's lead or if it's tin, then the answer is yes. And now I'll show you the steps that you need to follow depending on if the answer is yes or no. So you've already asked yourself the question, is the metal in the compound multi-charged? If the answer to that question is no, then these are the steps you do. When you say no, what that means is the metal in the compound is in a column with a charge. It's in the 1+ column on the periodic table, or the 2+ column, or the 3+ column. So if the answer is no, the metal is not multi-charged, then these are the steps you follow. First, you write the name of the metal, and metals always keep their name, so you don't change it. You write the name of the metal. The second thing you do is you write the name of the nonmetal, but you change the ending to IDE. Okay, so the metals keep their name, and then the nonmetal changes to have an IDE ending. So if the answer is no, the metal is not multi-charged, you write the name of the metal, followed by the name of the nonmetal with an IDE ending. So let's look at an example here. If we had to write the name of the compound here for AlBr3, the first thing I ask myself, is the metal in the compound multi-charged? Is it in the D block? Is it lead? Is it tin? And aluminum is not in the D block. It's in the 3+ column if you look on your periodic table. So the answer to the question, is the metal multi-charged, is no. So the first thing I do is I write the name of the metal. Well, Al is aluminum. So I write his name. followed by the name of the nonmetal with an IDE ending. In this case, the nonmetal is Br. That's bromine, but it has to end in IDE, so it becomes bromide. So for this example, the answer to the question, is the metal multi-charged, was no. So we wrote the name of the metal followed by the name of the nonmetal with an IDE ending. And that is what you do if the metal in the compound is not multi-charged. So what if the answer to the question, is the metal multi-charged, is yes? So that means the metal is in the middle. It's in the D block of the periodic table, or it's lead or tin. So if the answer to the question is yes, then these are the steps you need to do. And it's definitely more steps than if the answer was no. But the first thing you do if you answer yes, you crisscross any subscripts in the formula up, and you make them the charges. Subscripts are the little, small, sunken down numbers in a formula. So you crisscross them and bring them up to the elements to make them charges. And I'm reminding you here that metals always have a positive charge and nonmetals always have a negative charge. You're bringing up the numbers of the charge. And I'll show you how to do this in a couple examples so you can see if you don't quite understand right yet. But the first thing you do is you crisscross the subscripts up and make them charges. The next thing you do is you check the charge on the anion, the negative. Okay, you don't worry about the positive one right now. You look at the anion, the negative charge, and you see if that really is the charge of that element or that polyatomic ion. If it's correct, you move on to step 3. If it's not, you have to multiply that charge by a number to make it the correct charge. Whatever number you multiply it by, okay, to make that charge correct, you have to multiply the positive charge by the same number. It's kind of like if you do 1 to one side, you got to do the same thing to the other side. Okay, so if it's not right, you multiply it by a number to make it right, and then you must do the same thing to the positive charge. Then, what you do is, you write the name of the metal, followed by his charge in parentheses as a Roman numeral. So you have the charge listed now, and you simply write that charge as a Roman numeral in parentheses right after the metal's name. Because remember, the metals keep their name. But this time, you need its charge listed in parentheses because it's multi-charged, so it could have various charges. So we need to make sure we indicate the charge in the actual name. Followed by the nonmetal with an IDE ending. This is the same as previous. The only difference here is that you had to figure out the charge on the metal and write it in parentheses. So if you answer yes to the question that the element is multi-charged, then yes, you better have the charge in parentheses. You have to train yourself. If I answer yes, the first thing I do is crisscross up. Then I have to check the anion, and then I write the name of the metal with the charge in parentheses of Roman numeral, followed by the name of the nonmetal with an IDE ending. So let's do an example here. Let's look at this compound, Fe2O3. So the first thing you have to do is ask yourself, is the metal in the compound multi-charged? Is it in the middle? Is it in the D block? Is it lead? Is it tin? Well, if you look at this element, the first element listed is Fe. Fe is iron. If you look on your periodic table, it's in the D block. So the answer to that question is yes. As soon as you answer yes, the first thing you do is crisscross the subscripts up and make them the charges. So if you look here, this 2 has to go up to the oxygen, and this 3 has to go up to the iron. So it's important that you rewrite these things. So Fe will get the 3 that was with the oxygen, and since he's the metal, he's a 3 plus, and oxygen will get the 2 from the iron, and since he is a non-metal, he gets a minus. So the first thing we do after we said yes, the metal is multi-charged, we crisscross the subscripts up and we made them the charges. So whatever subscript is with the oxygen goes over to the iron. Whatever subscript is with the iron goes over to the oxygen. And it's important to remember that metals are plus, nonmetals are minus. Step 2 says you got to check the anion and make sure that that charge is correct. So right now we have oxygen at a 2 minus charge. When you look up oxygen on the periodic table, it's in the column that has a 2 minus charge. All the elements in that column will gain 2 electrons. So this is correct. So we don't have to worry about fixing it. We already know that it's right. So then we move on to step 3. We write the name of the metal. Fe is iron, followed by his charge in parentheses as a Roman numeral. Well, right now his charge is a 3 plus. So we put his charge in parentheses as a Roman numeral 3. So iron 3, followed by the name of the nonmetal with an IDE ending. Well, the nonmetal is oxygen. It has to end in IDE, so it's oxide. Iron 3 oxide. We answered yes, it was multi-charged, so we crisscrossed up immediately. We checked the anion's charge, and then we wrote the name of the metal with the charge in parentheses, the Roman numeral, followed by the name of the nonmetal with an IDE ending. It's very important that you're constantly always asking yourself the question when you see a formula, is the metal multi-charged? That determines what you do. Let's look at another example. ZnCl2. First thing I do, I ask myself the question, is the metal multi-charged? Is it in the middle? Is it in the D block? The answer is yes. However, we also made a note that if it's zinc or silver, the answer is no, it's not multi-charged. In this case, the element is zinc. So even though it's in the middle, the answer is no, because zinc always has a defined charge. It's not multi-charged. So the answer is no. So we follow the no steps. When the answer is no, we write the name of the metal. In this case, Zn is zinc, followed by the name of the nonmetal with an IDE ending. That's chlorine, so it's chloride. We don't need a charge in parentheses because the answer to the question was no. The only time you write a charge in parentheses is if the metal is multi-charged, because we are unsure of the charge. So you have to put the charge in parentheses in the name. If we are sure of what that charge is, like when we answer no, then we don't put the charge in parentheses. And it's very important that you're constantly checking and asking yourself that question when you're writing the name of a compound. So right here is just basically a summary of everything I've gone over. If you want to write the name of an ionic compound, you must ask yourself the question, is the metal multi-charged? What that means is the metal in the D block, in the middle? If the answer is yes, you do these steps. You crisscross up. Okay? You crisscross the subscripts up, make them charges. Then you check the charge on the anion to see if it's correct. If it's not, you'll have to multiply by a number to make that charge correct. And whatever number you multiply by to make it correct, you do the same thing to the metal's charge. And then you write the name of the metal, followed by his charge in parentheses as a Roman numeral, followed by the name of the nonmetal with an IDE ending. It's important to note that if you do have polyatomic ions anywhere in these formulas, polyatomic ions always keep their name no matter what. They don't change their ending. They're not multi-charged. So if you have a polyatomic ion, okay, they always keep their name and you don't worry about changing anything with them. Remember, in order to be multi-charged, you have to be in the middle. You have to either be lead or tin. If you meet that criteria, the answer is yes. Also remember, zinc and silver automatically give you a no answer. So any element that's in a column with a charge, or zinc or silver, automatically give you a no answer, and then all you do is write the name of the metal, followed by the name of the nonmetal with an IDE ending. And polyatomic ions still keep their name. So it's very important you remember to ask yourself that question all the time. And if the answer is yes, you do a defined set of steps. If it's no, you do another set of steps. If you answer yes, it's multi-charged, then yes, you better see the charge in parentheses as a Roman numeral. All right, so let's do some more practice here. We have a bunch of ionic formulas. So the first thing we do when we see an ionic formula, I know it's ionic because there's a metal listed, and ionic compounds always have metal, and metals are always written first. So the first thing we do, we ask ourselves the question, is the metal multi-charged? So in this first example here, KCl, the metal is K, potassium. So if you look on the periodic table, okay, find potassium, we realize potassium is not multi-charged. It's not in the D block, it's not lead, it's not tin, it's in the 1 plus column. So the answer to the question, is it multi-charged, is no. So when it's no, we write the name of the metal, potassium, followed by the name of the nonmetal with an IDE ending. Well, that's chlorine, but it has to end in IDE, so it's chloride. So KCl is simply potassium chloride. We answered no, it's not multi-charged, so no, we don't put any charge in parentheses. Let's look at the next example. Na3N. Ask yourself the question, is the metal multi-charged? In this case, the metal is sodium. Sodium is in the 1 plus column, so it's not in the middle. So the answer to that question is no. So when the answer is no, we write the name of the metal, which is sodium, followed by the name of the nonmetal with an IDE ending. Well, this is nitrogen, so that with an IDE ending is going to be nitride. So the answer to this Na3N formula, the name is sodium nitride. The next example, CrN. Ask yourself the question, is the metal multi-charged? So look up chromium, Cr is chromium on the periodic table, find it. It's in the middle, it's in the D block. So the answer to the question is yes. Once we know the answer to the question is yes, the first thing we do is crisscross the subscripts up and make them the charges. In this case, there are no subscripts, so each of them has a number 1. So the one from chromium will go up, and the other one from nitrogen will go up. So if you see it here, the one from chromium will go up to the nitrogen, the one from nitrogen goes up to the chromium. And they're not listed because you don't write ones in formulas. So chromium will have a 1 plus, because he's a metal, and metals always have a plus, and nitrogen will have a 1 minus. So we said, yes, the metal was multi-charged. The first thing we did was crisscross up. Second step says, check the anion and see if that charge is correct. So look at the -1, and that's nitrogen. Is his charge -1 on the periodic table? If you go to the periodic table and look up nitrogen, you see he's in the 3 minus column. So his charge is not right. His charge should be 3 minus. Well, what number do you have to multiply 1 minus by to get 3 minus? You have to multiply it by 3. So if you have to multiply him by 3 to make his charge right, you have to multiply the positive, the metal's charge, by 3 to make him now correct. So he's not 1 plus anymore, he's 3 plus as well. So we completed step 2. Step 3 says you write the name of the metal. Chromium, with his charge in parentheses as a Roman numeral, it's now 3, followed by the name of the nonmetal with an IDE ending. It's nitrogen, so again, it's going to be nitride. So chromium 3 nitride. We said, yes, it's multi-charged, so yes, you need a charge in parentheses. Let's look at the next one, PbO. Okay, is the metal multi-charged? Is it in the middle? Is it lead? Is it tin? Well, in this case, Pb is lead, so the answer is yes. As soon as we say yes, first thing we do is crisscross up. Again, there's no numbers listed, so each of them is going to be sending up a 1. So when you rewrite this, again, don't be afraid to rewrite it. Pb will be a 1 plus. He's a metal, so metals always get a plus. Oxygen will be 1 minus. If you look at step 2 says, check the anion, make sure it's correct. So look at oxygen. Is that the charge of oxygen on the periodic table? Go to the periodic table, look for oxygen. He's in the 2- column. So his charge should be 2-. So what number do you multiply 1- by to get 2-? 2. So you have to multiply the 1 plus by 2 and make him 2 plus. Now you can do step 3. You write the name of the metal, lead, with his charge in parentheses, a Roman numeral, 2, followed by the name of the nonmetal with an IDE ending, oxide. So the answer to this is lead 2 oxide. You said yes, the metal is multi-charged, so you crisscross up immediately, and yes, you better have a charge in parentheses. Let's look at the last one, CaSO4. Okay, so we ask ourselves the question, is the metal multi-charged? So calcium, find it on the periodic table. It's not in the middle. It's in the 2+ column. Therefore, the answer is no. You write the name of the metal, followed by the name of the nonmetal with an IDE ending. But if you notice, CaSO4, the SO4 is a polyatomic ion. You know it's a polyatomic ion because it's got 2 elements in it. So it is a polyatomic ion. So it doesn't matter. You answered no, you write the name of the metal, calcium, followed by the name of the nonmetal with an IDE ending, but he's polyatomics, and polyatomics always keep their name. SO4 is sulfate. Notice we did not write the charge in parentheses, a Roman numeral. Why don't we do that? Because calcium is not multi-charged. We answered no. When we answer no, it's not multi-charged, you don't put a charge in parentheses in the name. So what if we did it in reverse now? What if you were given a name and you had to write the formula of an ionic compound? Well, this is easier than writing a name because there's one set of rules that you always follow. There's no yes or no kind of deal like there was when we were writing names. So this is much easier. There's 3 basic steps. Okay? First thing you do, you look at the name and you write the symbol of each element from the name. And the cation is always written first, the plus is always written first, followed by the anion, the negative. So we write the symbols from the name. Then we write the charges for each. Well, where do you get the charges from? If it's a multi-charged metal, they have to give you the charge in parentheses as a Roman numeral. If you follow your rules for naming, when it's multi-charged, you must put the charge in parentheses. So it's right there in the name. You know the charge of the element from the name. Well, what if it's a polyatomic ion? Polyatomic ions keep their charge. So you know the charge if it's a polyatomic ion. Otherwise, if it's just an element, you get the charge from the periodic table. If it's in a column of the charge, you know the charge of that particular element. So we write the symbols from the name, we write the charges of each, and the last thing you do is crisscross. Instead of crisscrossing up like we did previously, we now crisscross down because these are charges. So if you look over here, these 2 elements have their charges, and in order to write the formula, you crisscross them down. So in this case, the aluminum has a 3+, we bring down just the number. Oxygen ends up with the 3, and then the oxygen is 2-. He sends his 2 down to the aluminum, and it becomes a subscript. Remember, subscript's always sunken down. You don't bring the plus and the minus, you just bring the numbers. And they crisscross. They switch. If possible, you would be able to simplify or reduce those numbers. In this case, you end up with a 2 and a 3. That is the lowest whole number ratio that you could have. If you had a 2 and a 2, they would cancel each other out and it'd be a 1 and a 1. That's what we mean by simplify. So if you are writing a formula for an ionic compound, it's always the same steps all the time, no matter what. You do the symbols, charges, crisscross. Simplify if you can. That's always the same, no matter if it's multi-charged or not. Those are the steps you follow. Symbols, charges, crisscross, simplify if you can. So let's do our first example here. What if we had to write the formula for calcium chloride? Well, I'm trying to write a formula, so it's always the same steps. I write the symbols, I write the charges, and I crisscross. So, first symbol, calcium. His symbol is Ca. Well, chloride. What element does that correspond to? It's a nonmetal with an ID ending. That corresponds to chlorine, so it's Cl. So I wrote the symbols. Now I have to write the charges for each. Calcium, if you look on your periodic table, is in the column with a 2+ charge. So you get that right from the periodic table. So he's 2+. Chlorine, look where he is on the periodic table. He's in the column that has a 1-. So I wrote the symbols for each. I wrote the charges, and now I crisscross. This 2 has to go down to the chlorine and be his subscript. This 1 has to go down and be the subscript for the calcium. So when I rewrite this, calcium gets the 1, but remember, we don't write 1s in a formula, so we just leave it as Ca. Then you write chlorine, which gets the 2. Remember, you don't bring down the actual plus and minus, you just bring the numbers down. So the formula for calcium chloride is CaCl2. That can't be simplified. It's a 1-to-2 ratio. So that's how you do it. You do the symbols, the charges, and then you crisscross. Simplify if you can. It's the same steps, no matter if it's multi-charged or not. That's how you write the formula of an ionic compound. Let's do another example that has a polyatomic ion in it. What if we wanted to write the formula for magnesium phosphate? It's the same steps whenever you're writing a formula. Symbols, charges, crisscross, simplify if you can. So magnesium, symbol for magnesium, Mg. Symbol for phosphate. Phosphate's a polyatomic. It's PO4. You have to realize that this says phosphate, not phosphite, which is another polyatomic, and not phosphide with an IDE ending. That would tell you it's the element phosphorus, just P. But in this case, it says phosphate, so that's PO4. So we wrote the symbols. Now we write the charges for each of these. Magnesium, if you go on the periodic table, is in the 2+ column. So it has a 2+ charge. Phosphate is always a 3-. It's a polyatomic, so you should know his charge. So we wrote the symbols, we wrote the charges, and now we crisscross. The 2 is going to go down to the phosphate. The 3 is going to go down to the magnesium. So when we rewrite this, Mg gets a 3. Remember, you don't bring the plus or the minus, just the number. And PO4 has to get the 2. The problem is you cannot change the 4 that's in the PO4. So when you have more than one of a polyatomic ion, you put parentheses around it and then put the proper subscript. If you change the 4 in PO4, you would change the polyatomic ion. So in this case, there's more than one. You have to put parentheses around it and then put the proper subscript. But the steps remain the same. To write a formula, symbols, charges, crisscross, simplify if you can. In this case, you cannot simplify a 3 and a 2. It's already in the lowest whole number ratio. So here's just a summary of the steps for writing a formula for an ionic compound. If you remember, it's basically 3 easy steps. You write the symbols of each from the name. You do the charges. And then you crisscross those charges down and make them the subscripts. But don't bring the plus and the minus. Remember, if it's a 1, you don't write it. If it's possible, you do simplify them. And I'll show you some more examples. But no matter if it's multi-charged or not, you always do the same steps for writing a formula. Symbols, charges, crisscross, simplify if you can. All right, so let's do some examples here of some ionic formulas. Okay, remember, these are always the same steps. If you're going to write a formula, you do the symbols, the charges, crisscross, simplify if you can. So the first thing we're going to do, first example, lithium sulfide. Symbols. Lithium is Li, sulfide is S. Notice it ends in an IDE ending. That tells you it's just the element sulfur. It doesn't say sulfate or sulfite, which would be the polyatomic ions. It's an IDE ending. So it's just the element from the periodic table. In this case, sulfur is S. So we wrote the symbols. Now we do the charges. Lithium is a 1+ charge. It's in the column that has a 1+ charge on the periodic table. Sulfur is in the 2 minus column on the periodic table. So I wrote my symbols, did my charges, and now I crisscross. Okay? Remember, you don't bring the plus and the minus, just the numbers, and if it's a 1, you don't write it in the formula. So this ends up being Li gets a 2 as a subscript. Remember, subscripts are sunken down. He gets that from the sulfur. And the sulfur gets a 1, which we don't write. So the formula for lithium sulfide is Li2S. Okay? So we did symbols, charges, crisscross, simplify if you can. We can't simplify. It's a 2-to-1 ratio. It's already in the lowest whole number. Let's do the next example. Tin 2 oxide. So let's write our symbols. Tin is Sn. Oxide is oxygen. Charges. Now, tin acts like a multi-charged metal. So his charge is given in parentheses in the name. So he's a 2 plus charge. Okay? If you look him up on the periodic table, you're not going to know his charge. His charge is given in the name. Oxygen on the periodic table, his charge is a 2 minus. So we wrote the symbols, we wrote the charges, and now we crisscross. So tin gets a 2 from the oxygen, and oxygen gets a 2 from the tin. However, you can simplify these. A 2 and a 2 simplify. They cancel each other out. So the formula of tin 2 oxide just ends up being SnO, 1 to 1. And you don't write the ones. Okay, so there was a good example of where you needed to simplify. Symbols, charges, crisscross, simplify if you can. In this case, you can simplify. Let's do the next example. Magnesium, Mg. Fluoride is F. Go to the periodic table and get their charges. Magnesium's a 2 plus. Fluorine's a minus. So I crisscross. I don't bring charges down. We don't put charges in the formula. So when we rewrite this, magnesium gets the 1 from fluorine, which we don't write. And then the fluorine gets the 2 from the magnesium. So magnesium fluoride is MgF2. Last example, copper 2 sulfate. Symbols, charges, crisscross, simplify if you can. Symbol for copper, Cu. Sulfate is a polyatomic ion. It does not end in IDE, so it's not just the element. It's a polyatomic ion, and sulfate's SO4. So now we do the charges. Copper is a 2 plus because it's in parentheses. Sulfate is 2 minus. That's the charge of sulfate, the polyatomic ion. When you crisscross, again, you'll notice that this is a polyatomic ion, so you would need parentheses around it. You cannot touch the 4 in SO4. You change the polyatomic. But in this case, you're bringing down a 2 and a 2, so they would simplify and cancel each other out. The answer would just be CuSO4. You can put parentheses around polyatomic ions all the time if you want to, but if there's only one of them, like there is in this case, there's one SO4, you don't have to. The only time you need parentheses around a polyatomic is when there is more than one. So for any formula, it's symbols, charges, crisscross, simplify if you can.